Assessing data quality in market research. In this lesson, we will solve a real-world problem. How do we assess and improve data quality in customer surveys and market research datasets? Many business decisions rely on survey or customer data. Poor data quality can lead to wrong conclusions. You will learn how to explore, diagnose, and handle common data quality issues using Python. By the end, you will produce actionable insights by ensuring your data is reliable before analysis. Running the cell now. We import the warnings library so we can control and silence any unnecessary warning messages. We import pandas because it is the main tool for data manipulation and analysis. We import NumPy as it is used for data simulation and numeric operations. We import matplotlib as PLT so we can create visualizations and charts for our analysis. We import opaml because we will load real, public datasets for market research analysis. We filter out warnings so that our output stays clean and easier to interpret. Running the cell now. What is market research data, and why does quality matter? Market research data comes from customer surveys, feedback, sales, or marketing experiments. Most datasets include multiple columns, respondent demographics, product ratings, open-ended feedback, or behavioral signals. Beginners often forget to check for mistakes like missing data, inconsistent codes, or survey fatigue, which can lead to misleading analysis. Good data quality is the foundation for accurate, actionable business insights. Running the cell now. Let us start by loading a real customer satisfaction survey dataset for analysis. We retrieve the dataset from OpenML, a public repository of machine learning data. We get the data as a pandas data frame for easy analysis. We print the shape of the data to see how many records and fields there are. We preview the first 3 customer records to understand the kind of data available. Running the cell now. This dataset has 7,043 rows and 20 columns, showing a rich collection of customer attributes and service usage details, like gender, tenure, and contract type. Notice the mix of categorical and numerical data, which highlights common challenges in market research such as varying data types and potential missing values. Checking this shape and previewing key columns is crucial for assessing data quality before deeper analysis. Try looking up the dataset ID in OpenML to learn more about the survey background. Beginner, which columns and customer features are in the data? The customer satisfaction survey includes demographic and service columns such as gender, senior citizen, tenure, payment method, and churn. Each row represents a unique customer record. Columns represent survey responses or customer attributes. Identifying the variables in your data is the first step to understanding data quality. Running the cell now. Before analyzing the customer data, let us check for missing values in each column. We calculate the number of missing values per column to spot any problematic features. We print only the columns with missing values to focus on quality issues. Running the cell now. The output shows no missing values in any columns, which means every customer record is complete for all features like gender, senior citizen, tenure, payment method, and churn. This is important because it confirms the data quality is good, allowing us to confidently analyze customer attributes without worrying about gaps. If you find many missing values in a key column, think about how it could affect your analysis or business insights. Let us look at the possible responses in the churn column, which is the target for many customer analytics projects. We print out all unique values so we can spot any mistyped or inconsistent survey codes. Running the cell now. This output shows the unique values in the churn column, revealing that customers are categorized as either yes, churned, or no, not churned. Noticing these distinct categories helps confirm that the column is categorical and ready for analysis in the context of customer retention. This step is crucial for understanding the data's structure before exploring relationships with other features. Now we check and visualize missing values in a safe way. First, we calculate the total number of missing values for each column and sort them in descending order. Next, we filter the results to keep only columns that actually contain missing values. We then check if there are any columns with missing values. If there are, we create a new figure with a specific size for better visibility. We plot the missing value counts as a bar chart. We add a clear title to describe the chart. We label the x-axis to represent the columns. We label the y-axis to represent the count of missing values. We display the plot. If no missing values exist, we move to the else condition. In that case, we print a message indicating that the dataset is clean. Running the cell now. This output tells us that the dataset has no missing values, meaning all customer records have complete data across every column like gender and tenure. This is a good sign for data quality and ensures that our analysis won't be affected by gaps in the survey responses. Identifying such features early helps us trust the data before moving on to deeper exploration. This defensive approach ensures our analysis does not break when datasets contain no missing values. Always validate before visualizing when building automated data pipelines. For another example, let us load a real bank marketing campaign dataset. We retrieve a campaign dataset from OpenML. We load it as a data frame for analysis. We rename the columns for business context and easier interpretation. We print the size of the marketing dataset. We preview the first 3 campaign records to understand who was targeted and how they responded. Running the cell now. This output shows the dataset shape, 45,211 rows and 17 columns, and previews the first 3 customer records with key variables like age, job, and marital status. Notice how each row is a unique customer, and columns capture demographic details and campaign info, aligning with the lesson's goal to recognize what features are in the data before further analysis. What extra steps would you take to quality check categorical columns like response or the job? Checking for duplicates is another basic but critical data quality check. We count how many rows are exact duplicates in the marketing campaign data. We print the number of duplicate records. Too many duplicates could bias your analysis. Running the cell now. This output tells us there are no duplicate rows in the marketing dataset, meaning each customer record is unique. This is important because duplicates could skew analysis or misrepresent the true customer base. Ensuring data uniqueness is a key early step in validating data quality before exploring customer features. Market research datasets sometimes contain mixed or incorrect data types. We check the data type of every column to make sure values are stored as expected. Running the cell now. This output shows the data types of each column in the customer dataset, highlighting a mix of numeric types like uint8 and float64, alongside categorical variables. Noticing these types helps confirm that demographic features such as age, job, and marital status are correctly categorized for analysis. Understanding this data structure is essential for preparing the data and choosing the right methods for further exploration or modeling. If a column meant to be numeric is type object, investigate why. This could signal dirty data. To understand if survey responses or campaign outcomes were consistently recorded, let us get the frequency counts for the response column. We display counts for all unique values, including blanks if present. Running the cell now. This output shows the count of each unique value in the response column, where 1 appears 39,922 times and 2 appears 5,289 times. Noticing these frequencies helps us understand the distribution of customer responses, which is key for evaluating data quality and identifying majority and minority classes before further analysis. It confirms that the response column is a categorical feature representing different customer reply types. When columns like age or account balance have errors or wild values, results can be misleading. We print the minimum and maximum values for age and a balance. This helps spot any outliers or impossible values that might reflect data entry errors. Running the cell now. The output shows the minimum and maximum values for the age and balance columns, revealing an age range from 18 to 95 and a balance range that includes negative values as low as -8,019. Noticing these extremes helps us identify potential outliers or data entry issues, which is crucial for assessing data quality early on. This step ensures we understand the scope and reliability of key customer features before deeper analysis. A histogram of age helps show whether there is any age heaping or strange patterns. We make a moderate-sized histogram using 30 bins. We use sky blue bars and black edges for clarity. We give the plot a descriptive title for business context. The x-axis shows customer ages. The y-axis shows the number of customers per age. We display the chart for review. Running the cell now. This histogram shows the distribution of customer ages, with counts grouped into 30 bins. Notice the overall shape and any spikes, which can reveal common age groups or unusual gaps in the data. Understanding the age spread helps assess data quality and guides how you might segment customers in further analysis. Now we focus on open-ended survey feedback, which is often the most challenging to clean and analyze. Let us view a small set of customer feedback records. We print the first 3 text comments. We calculate the length of each comment. Very short or blank feedback can be an early sign of survey fatigue or spam responses. Running the cell now. This output shows the first 3 customer feedback entries and the character length of each feedback comment. Notice how that feedback column contains text responses with varying lengths, which indicates differences in how much customers wrote. Understanding these text features helps assess data quality and completeness before deeper sentiment or topic analysis. Text inputs can contain responses in the wrong language or even gibberish, which reduce data quality. We define a simple function to check if feedback is English by trying to decode as ASCII. We apply the function to all feedback comments. We print any detected as non-English or gibberish. A good market research study will flag or remove these from key analyses. Running the cell now. This output shows that no customer feedback was flagged as non-English or gibberish, meaning all text entries contain only standard ASCII characters. In the context of exploring customer features, this confirms that the feedback column has valid, readable data, which is important before analyzing customer sentiments or comments. Checking data quality like this ensures the feedback is usable for further insights. Net Promoter Score surveys must use a strict 0 to 10 scale, but data entry mistakes can creep in. We create a synthetic NPS dataset with reproducible results by setting the seed to 42. We preview the first 3 NPS survey rows. We search for any records where NPS_score is not between 0 and 10. We print the count of invalid records. This is important for reliable customer advocacy insights. Running the cell now. The output shows the first 3 rows of the NPS survey data, highlighting key columns like customer ID, age, region, and NPS_score. Notably, the check for invalid NPS scores confirms there are 0 records outside the valid 0 to 10 range, demonstrating data quality in this important satisfaction metric. This step ensures the customer features are accurate before further analysis. Could you set assertions or rules to prevent invalid score entry in real survey systems? Seeing the shape of NPS scores helps diagnose whether customers understand the survey scale or if there is bias like skipping certain numbers. We create a compact histogram with 11 bins, 1 for each possible NPS value. We use green bars and slightly narrow width for visibility. We make the x-axis show all possible NPS scores clearly. We title the plot for executives. The x-axis shows the scores from 0 to 10. The y-axis shows the count of customers with each score. We show the plot for review. Running the cell now. This histogram shows the distribution of NPS scores from the survey, with scores ranging from 0 to 10 on the x-axis and the count of responses on the y-axis. Notice the shape and any gaps or spikes that could indicate unusual patterns or response bias. This helps us verify data quality by identifying potential issues before deeper analysis. Data is often imperfect. Let us simulate missing data into monthly charges, a key business variable. We make a copy of the customer dataset to avoid destroying our original. We randomly select 10% of the rows and set monthly charges as missing, using random_state equals 42 for reproducibility. We print the number of missing values created. This helps you practice realistic missing data handling. Running the cell now. This output shows that 704 customer records now have missing values in this monthly charges column, which simulates incomplete survey responses. Noticing the count of missing values helps us understand data quality issues to handle before analysis. This step emphasizes the importance of identifying which features may have gaps, as seen here with a key service attribute. How would you handle missing values? Try imputation, exclusion, or business rule-based fixes. Analysts often make grouping errors, especially between categorical and continuous columns. We attempt to group by a monthly charges, which is numeric and not ideal for group by. We wrap the code in a try-except block to catch and print the error message if it fails. If an error occurs, we print it so you can diagnose and learn from the mistake. Running the cell now. One classic error is averaging ordinal survey scales like NPS or Likert, which can mislead business outcomes. We calculate the mean NPS, but remember that true NPS is computed differently, promoters minus detractors. We print the average, but warn that it is not the industry standard metric. Running the cell now. This output shows the average NPS score calculated from the NPS_scores column, which is around 4.89. However, because NPS is based on categorical scales, detractors, passives, promoters, interpreting the mean as a typical score is misleading. This highlights the importance of understanding each column's data type and appropriate analysis methods before drawing conclusions. For practice, try computing the official NPS, percent promoters, 9/10, minus percent detractors, 0 to 6. Best practices, segmentation, crosstabs, index construction, trend analysis. Segmenting by customer age, tenure, or region uncovers actionable subgroups. Cross-tabulation helps reveal relationships between two categorical fields, such as churn and contract type. Building custom indexes, such as satisfaction scores, and running trends over time is critical for decision support. Always start with data quality before segmentation, as bad data can hide or create fake patterns. Running the cell now. A business-critical pattern is looking for quality and satisfaction differences across customer segments. We group the NPS scores by customer region and calculate the mean NPS in each segment. We print average NPS score per region so that marketers can target improvements. Running the cell now. This output shows the average NPS, Net Promoter Score, segmented by customer region, highlighting regional differences in satisfaction. Noticing that the North region has the highest mean score while the East is the lowest helps identify target areas for improvement or investment. This segment-level insight aligns with the lesson's focus on using segmentation to uncover actionable subgroups for tailored strategies. Share this segment analysis with your marketing team or add it to a business dashboard. Cross-tabulation is a classic technique to compare relationships between key variables like churn and contract type. We create a crosstab between the churn field and contract type to uncover relationships. We print the resulting table to see if certain contracts are more likely to result in churn. Running the cell now. This crosstab shows the relationship between customer churn status and their contract type, clearly highlighting that churn rates are much higher in the month-to-month group compared to 1-year or 2-year contracts. Notice how the counts under yes drop significantly for longer contracts, indicating stronger retention with longer commitments. This segment-based insight supports targeted retention strategies and underscores the value of cross-tabulation for uncovering actionable patterns. Sometimes, analysts need to construct summary scores to represent overall customer satisfaction. We map service feature responses to 1 or 0 to indicate presence or absence. We compute the mean score for each customer across 3 service dimensions. We print sample satisfaction index values as a new quality metric. Running the cell now. This output shows the first 5 values of a custom satisfaction underscore index, averaged across the 3 binary service features after mapping yes/the nos to 1 or 0. Notice the range from 0 to 0.67, indicating varying levels of customer satisfaction. Creating such an index simplifies trend analysis and enables segmentation based on overall service satisfaction, aligning with our goal to build meaningful, composite metrics for better decision support. Try adjusting which service features are included in the satisfaction index for your own business context. Watch our YouTube playlist for more data quality and analytics tips for market research. Trend analysis helps businesses identify when churn is most likely to occur. We group the data by tenure and calculate the proportion of churning customers for each tenure group. We visualize this trend with a simple line plot. We label the y-axis as the churn proportion. We give the plot a business-friendly title. We display the chart to highlight at-risk tenure periods. Running the cell now. This line plot shows how the proportion of customers who churn varies across different tenure lengths, highlighting key trends in customer retention over time. Notice the shape of the churn curve, whether it rises, falls, or stabilizes, which helps identify critical periods where intervention may reduce churn. This visualization exemplifies best practices in trend analysis by segmenting churn by tenure to inform targeted retention strategies. Let us solve a tiny end-to-end data quality problem, from raw customer satisfaction data to an actionable insight. Step 1, we copy the data for safe cleaning. Step 2, we clean the target column, fixing capitalization and extra spaces in churn responses. Step 3, we fill missing values in monthly charges by plugging in the column median, which is a safe statistic. Step 4, we calculate and print the churn rate, a key business metric. This gives us a high reliability churn metric for business decision making. Running the cell now. This output shows the overall churn rate after cleaning the dataset, confirming that about 26.54% of customers have churned. Notice how the data cleaning steps, trimming white space, fixing capitalization, and imputing missing values, ensure accurate calculation by addressing data quality issues. Establishing a reliable churn baseline like this is essential before segmenting or analyzing patterns in churn behavior. Practice: could you apply the same cleaning and metric building process to NPS or satisfaction indexes? Subscribe to our YouTube channel for case studies and more advanced practical tips.